Good day, Mom. We are the reporter for today. So today we will talk about basic electricity training. For our objectives, to be able to identify and implement theory of Ohm's law, define electrical terms, to be able to describe the interrelationship between voltage, current, and resistance in electrical circuit, to be able to identify digital multimeter features and its capabilities, to be able to correctly use the digital multimeter and understand your findings when taking electrical measurement in normal and fault finding situations. Basics of electricity. It introduces different types of energy, direct electrical energy, heat energy, atomic energy, mechanical energy. It emphasizes that energy can be converted from one to form another. Like for example, oil, heat, water, steam, turbine mechanical energy, generator, handle sa mag-form siya og electrical energy. So what is electricity? Matter is made up of molecules, which are composed of atoms, and an atom consists of three subatomic particles, ang protons, neutrons, and electrons. The nucleus in the center of the atom containing protons and neutrons. So makita ninyo dire, ang kaning blue mao to siya gitawag nga protons, ang kaning white is gitawag nga neutrons, and then ang kaning na dire sa kilid nga kaning ay sa gawas nga naa sa outer orbit mo ni siya ang gitawag nga electrons. So the ability of an atom to conduct electricity depends on the number of electrons in the outer orbit, the distance of the outer orbit from the nucleus of the atom, the density of the atom within the elements. Rules of electron arrangement. So mo ni siyang rules. If the atom has only one orbit, maximum number of electrons on orbit is 2. And if atom has more than one orbit, maximum number of electrons in outer orbit is 8. And then good conductors like gold, silver, and copper have only one electrons on their outer orbit. Mercury has 2, aluminum has 3, and then carbon has 4. The image shows atomic structures of copper, a good conductor, and carbon, a semiconductor. Copper atom has 29 protons and 29 electrons, while carbon atom has 4 electrons in its outer orbit, meaning it is a semiconductor. Excess of electrons creates a negative charge, and their absence results in a positive charge. Opposite charges will attract each other because they have positive and negative, while like charges repel each other because both of them have positive. Normally, an enormous number of electrons flow. The basic unit of electrons charge in a coulomb. 1 coulomb equals 6.25 times 10 electrons. So, mao ni siya ang example sa electricity na ang battery, switch, load, conventional flow, electron flow. Ang kaning battery is naga-provide siya og energy. Ang switch is siya ang nagakontrol sa circuit. Ang load is nagakakuan siya og light, bump the light up when electricity flow. Electron flow is naga-move siya from negative terminal to positive terminal. So nakita niyo mo dyan kung asa siya naga-move. And then ang conventional flow moves in opposite direction from positive to negative. So mao na siya kaning na blue conventional na diri siya nagka-move sa opposite direction. So the loss of electron by an atom makes it positive ion. Therefore, it will attract an electron from a neighboring atom to become balance. So next is electricity. Electricity can be produced using different methods. It can be generated through chemical reactions such as battery. And for a large amount of electricity, electromagnetic generators are used. So next is current. Current is the flow of electrons. Conventional current is in opposite direction of the electron flow. Electricity moves from high voltage to low voltage. Unit of current is ampere. And then current is measured using an ammeter, which is connected in series with the circuit. Polarity is important in DC. Meaning sa DC is direct current. And then next is potential. Potential describes the ability to do work in an electrical system. And then voltage, defined as the work done to move a unit positive charge from a point of lower to higher potential. Unit of voltage is volt or V, measured by a voltmeter which is connected across the source. And then source of voltage include batteries, DC generators, and alternators. It can be alternating current or AC or direct current DC. Polarity in DC or direct current is important sa mga nato kung giingon sa mga importante ni siya because it fixes positive and negative terminal. Equivalent to two water tanks connected by pipe water flows.
And now let's proceed to the fundamentals of electricity. When we say fundamentals of electricity, these are the basic components that are electrical devices needed to generate electricity and to function well. These are the voltage, current, resistance, and etc. So let's discuss first what is voltage. When we say voltage, it provides the electrical pressure or force that enables the current or electrons to flow. It is the difference in electrical pressure between 2 points in a circuit. It is also measured in units called volts, and the symbol for voltage is capital letter E. So when we say voltage, this is also known as electric potential difference, in which the pressure or force drives electric current through a circuit. It is measured in volts. So, mao na siya ang voltage. So, next one is the resistance. Resistance is opposite flow of current. So, the unit for resistance is ohms. And it is measured by ohmmeter connected across it. It depends upon type of material, area, or length kung unsa ka taas ang resistance sa tuwang mga devices. Resistance produces heat when current flows through it. Fixed and variable resistor. So, resistance is a restriction to current flow. Increasing resistance will reduce flow of current. Also, electrical resistance is measured in units called ohms. They are abbreviated by the letter R, and the symbol for resistance is omega. So, when we say resistance, it is the opposition to the flow of electric current. So, it depends on the material, length, and cross-sectional area of the conductor. So, the higher the resistance ang naa sa ato ang devices is, the lower the voltage. Tapos, if lower ang resistance sa ato ang devices or electrical mga device, is the higher ang iyahang voltage. So, ato po ay dugang unsa dining current. So ang current is the flow rate of electric charge. So mo ni siya ang flow sa power sa electricity, typically measured in amperes or capital letter A. It's the result of the voltage applied across a circuit, taking into account the resistance. So muna siya ang current, ang flow sa electricity sa ato ang mga devices. Next one is the inductor. So when we see inductor, it is coiled of wire, opposite change in current, and it is used to create magnetic field for rotation. And the unit for inductor is Henry, and it is used in either open or short circuit or inductor. So when we say inductor, these are a coil of wire typically wrapped around a magnetic core that stores energy in a magnetic field when an electric current flows through it. So here are the process on how to or on how the inductors work. First is when an electric current flows through the coil, a magnetic field is generated. And if magnetic field induces an electromotive force in the coil, which opposes changes in the current. And as the current changes, the magnetic field also changes, causing the inductor to store or release energy. So mauto siya ang inductor. So next one is ang capacitor. Capacitor is two metal plates separated by an dielectric or max volts mm, which a medium can withstand without breakdown. And capacitor gets charged when voltage is applied. So the unit of capacitor or capacitance is farad. So when we say capacitor, it is the device that stores energy in the form of an electric field, and it consists of two conductive plates separated by a dielectric material or the insulator. So these are the process of the capacitor works. So first, when a voltage is applied across the plates, electric charges build up on the plates, and when dielectric material between the plates prevents the charges from flowing directly between them, and as the voltage increases, the electric field between the plates strengthens and it's storing energy. So mauto siya ang capacitor. So next is ang insulators and conductors. When we see conductors, these are the materials that have a low resistance to current flow, and the examples of conductor materials are copper and aluminum. So high ang iyang ibali conductor sila. And the conductors are used in electrical circuits to connect components to one another. Ibali magband sila to produce electricity. So conductors are usually wrapped in insulators to isolate from one another. Next is ang insulators. So insulators are the materials that have a high resistance to current flow, and the Example for these are glass, rubber, and dry air. So in electricity, the conductor and insulator are the two types of materials that play a crucial role in the flow of electric current. So ang conductor, muna siya ang material that allows electric current to flow through it with minimal resistance. So, high ang iyang voltage. Conductors have free electrons that can move freely carrying electrical energy. So, example na is mga metals, carbon, salt water, and human body also an example of conductor. So, on the other hand, ang insulator is the material that resists the flow of electric current and prevents the transfer of electrical energy. So, insulators have tightly bound electrons that are not free to move. So, ang insulators is example na is mga woods, plastic, glass, rubber. So, mo na siya ang mga example. So, next is ang basics of electricity. So, first, ito ang i-discuss what is Ohm's law. So, Ohm's law is a relation between three quantities learned. So, muna siya ang iyang formula. V is equal to I multiplied by R. The R here stand for resistance of circuit in ohms. The V is applied voltage in volts. And the I is current in amperes. So, voltage is equal to current multiplied by resistance. So, ang Ohm's law diha na gi-state diha ang current sa itong mga electric power is directly proportional sa iyang voltage but inversely proportional sa iyang resistance. Muna siya ang Ohm's law. So, muna siya ang mga formula nga gamiton sa pagkuha or pag-solve sa kung pangitaon ang voltage, muna siya ang iyang formula. Voltage is equal to current i-multiply nato siya sa resistance, makuha nato ang voltage sa tuang device. So, if ang resistance ang ipangita mo ni siya ang atong gamiton nga formula. Resistance is equal to voltage over or divided by current. So, if ang current naman ang gipangita, itong gamiton ni nga formula, current is equal to voltage divided by its resistance. So, mo ni siya ang ginatawag nga Ohm's law pie chart. Mga formula nga gamiton sa pagkuha sa voltage, resistance ug sa current sa electrical nga mga devices. Next na to nga i-discuss is ang DC power or ang direct current power. So, this direct current power, this is the power consumed in industry is almost AC or alternative current or alternating current. Power in DC circuit is P is equal to V multiplied by I is equal to I multiplied by R and multiplied by I. So, ang P is ang power, ang V is ang voltage, ang I mo na siya ang current, and ang R mo na siya ang resistance. So, different types of load have different effect on power source, and the unit of this power is mechanical. The unit of mechanical power is horsepower. So, ang 1 horsepower is equivalent to 0.746 kilowatts, and this is measured by watt meter. So, when we see DC power or direct current is type of electrical power where the electric current flows in one direction only, from positive to negative, with no reversal or of direction. Muna siya ang DC power direct. So, muna siya ang application of the power formula. Example. So, ang atong gamiton nga formula is the PPT. Power is equal to current multiplied by voltage. So, para makuha nato ang power nga gi-consume sa ato ang resistor, atua sa una pangitaon ang total current. So, muna siya ang mga given. Ang voltage is given na, which is 10. So, para atong solve ang total current, ato ang 10 nga volts sa 10 ohms. So, ang ohms diri is muna siya ang resistance. So, ang volts diri ang 10 is ang voltage. So, 10 volts divided by 10 ohms is equal to 1 ampere. So, ampere ang unit nga sa current. So, kaya nakita naman nato ang total current, atuan lang ipangitawon ang power nga consumed by the resistor. So, P or power is equal to current nga 1, gi-multiply nato siya sa voltage nga 10. So, ang iyang result is 10 watts. So, muna siya ang power nga na-consume sa resistor. Next is the unit of power in mechanical system is the horsepower or HP. 1 horsepower is equal to 0.746 kilowatts. To convert horsepower to kilowatts, just need to multiply the horsepower to the 0.746 kilowatts, which is the constant for horsepower. So, example, horsepower i-multiply na sa 0.746 kilowatts. So, if ang horsepower is equivalent to 50, ato lang siya i-multiply aning constant nga 0.746. So, ang iyang result is 37.3 kilowatts. So, therefore, if ang horsepower motor is 50, ang iyang makonsume is 37.3 kilowatts of power. So, mo to siya ang DC power. So, let's proceed to AC power. When we see AC power or alternating current power, it is a quantity in which periodically passes through a definite cycle of changes. In alternating current, RMS values are used. So, AC power is consumed by different types of load. such as inductive, resistive, and capacitive. So AC power is given by this formula. P is equal to V multiplied by I and multiplied by cos. So, ang symbol for AC source is, and also AC power is measured by wattmeter. So, ang unit ani is watts. So, when we say AC power, it is the type of electric power where the electric current periodically reverses direction, oscillating at a specific frequency. So, mauto siya ang AC power or alternating current power.
Now, let's proceed to the electrical term. The following table shows some common electrical terms, their abbreviation, units of measure, symbol, and measuring instrument. Term: current, abbreviation I, unit ampere, symbol A, measuring tools ammeter. Voltage, abbreviation E, unit volt, symbol V, measuring tool voltmeter. Resistance, abbreviation R, unit ohm, measuring tools ohmmeter. Power, abbreviation P, unit watt, symbol W, measuring tools wattmeter. So, basic of electricity. So, series of circuit is an electrical circuit where components are connected end to end, forming a single path for the current to flow. So, one path for current flow can have more than one load. Example, resistance. So, total load is sum of individual loads. Some voltage loss takes place across each load and is called as voltage drop. Sum of voltage drop across each load is equal to applied voltage. Currently through each load is same. Open and short. Example, chain of small bulb. Now, open and short circuit. So, open circuit is a break in electrical path preventing the flow of current. Imagine a broken wire in a circuit. So, example, a light bulb's filament breaks, creating an open circuit. The light bulb won't turn on because electricity can't flow through the broken filament. So, diri sa itong example is, gitry niya og pasiga ang suga. And then karon pag try niya siga, dili mo siga kay tungod di ay naay dili makadagan ang kuryente sa wire. Kay naay diferensya or naay depekto niini. Then ang short circuit is an unintended path for current to flow, often bypassing the intended load, like a light bulb. So think of a wire directly touching another wire, creating a low resistance pathway. So example po niini sa short circuit is a fried wire in a toaster touch its metal casing. This creates a short circuit, potentially causing spark, overheating, or even a fire. So, para mas dali gid nato masabtan, ang open circuit stop the flow of electricity completely. So, automatic siya ma-stop. Di na siya dagan. So, ang short circuit po, di-allows ang electricity to flow in an unintended way, often with dangerous consequences. Delikado gyapon siya no, mo dagan ay mo flow ang kuryente, pero delikado po siya kay naipuruhan nga masunog. If a short occurs in a parallel circuit, most of the source current will flow through the short because the current takes the path. So, less resistance. So, if we can see in here on screen, so, nakita na to no nga R1, R2, R3. So, diri most current will flow through short. No current will flow through R2 or R3. So, diri nakita na to no nga, wala naka dagan ang kuryente sa R2 R3. So diri ra siya taman sa R1 lang. So dali naman siya makita ra ninyo. Ana siya. So diri ata sa fundamentals of electricity. So diri sa fundamentals of electricity na ay tulo ka kakusugon sa klase sa kuryente. So sa primero is kanang mild lang, dili ra kayo lala. Second is murag na gid 50-50. Then diri sa last na gid wa na. Patay na gid ka diri. So diri na to, first na to is ang kaning it tangles. So diri kay mura ni siya kanang nakuryentihan ta bawa. Example ani is nagsaksak ta, nagcharge ta. Karon kay murag na-feel ta ng kuryentihan niya, murag moigking bitaw ta. So makita, ay nakuryentihan ko ingana. Mura rag kanang nakuara ka ba nga nakahinumdum ra ka nga or na-realize nimo na kuryentihan ka. Ingana siya. Murag na-feel na nato nga nakuryentihan ta. So second is kaning 50-50 kanang difficult breathing na. So diri agyud sa kaning difficult breathing na, diri ang imong impact sa kuryente sa imong lawas is di na gid siya basta-basta. Kusog na gid siya. Kay diri naman nga murag puruhan nga murag tabangon na ka kay tungod sa kuryente nga kusog kayo ni kuan sa imong lawas, naglisod pud imong lawas og kuan sa kuryente. Ana siya. So, 50-50, madala tag hospital na yan nga ni. So, kaning last yun, mo gid ang pinakakusog na kuryente. Diri kay severe burns na ginidri So, makita ba taan ng kuan nga pag once mga kuryentihan og kusog kaayo, di ba? Kada murag masunog atong lawas. Ingana. So, wala gid nga mabuhi pa ta ana. So patay gid ta pag once kanina kay tungod sa kakusog sa kuryente nga naa niini. So mao ta ng mga live wire ingana di gid ta magpa taka-taka ana kay dahil nga mamatay ta nagmatandog nato na siya. So diri ata sa digital multimeter description. So ang digital multimeter gina-measure yung electrical characteristic. Measure multiple types of electrical characteristic with a single device. Function as a ohmmeter, ammeter, and voltmeter. Includes an AC as well as DC voltage range. Provide a display or screen. So kanidri daw natay makita nga na screen niya. So includes option for an analog format. The accuracy of the flock meter is specified as of the reading plus number niya of less significant digit. So diri kita ninyo sa atong screen. So mo ni siya ang digital multimeter. So nakakita na ba mo ani? So wala pa no. So kani siya kung kasagan nakakita na mo ani, kasagan magamit ani sa mga electrician. Ani kay mga taga-silko, na sila may ani gyud kay kani dira po na ko nakita katong nagtaon sa mga kuryente, electrician na siya ing ani. So diri ana nga kani siya nga digital DI kay na siya kaning niya kay diri na to makita nga na AC voltage, DC voltage, DC millivoltage, resistance, load test, AC current, DC current. So kahit makita natin siya sa kaninga digital nani diri kita mo ni kay nailingin. So kay sa lingin niya sa gawas anak niya kinbali na diya ang nakabutan ng mga AC, DC nga na mga voltage. So pag to turn the meter on, turn the rotary switch from the off position. The meter perform a self-test to start taking reading. So diri ibutan sa nato siya sa off no. Kay pag once kaning positive kaning red o black, ito ni siyang makunik dito sa kuryente nga atong gitestingan or unsa ba na diha like sa kanang bitang sa kanang kwintador nato yung ana ginatest kung unsa ba kakusog imong kuryente nga na ginagamit ni siya. So diri mag-start din na siya og mutuyok na nag-iyaha. Siya na magbasa na kung asa ba dapat imong kuryente, AC ba na siya, DC ingana or load test lang ingana siya na magkuan mutuyok nag-iyaha. So muna ni siya diri ang voltage measurement, diri ginatest niyang voltage measurement. So nakita to na plus og negative. So, ang positive mo ni si red, negative si black. So, gi-measure yung parallel across item to be measured. So, di ba, tanawa, nakita na to, no? Nituyok na siya. Nituyok. So, diyan na mabawaan kung unsa ka kusog sa kuryente or asa may dapit ang depekto. So, dali agad kay ni siya to matest. Pinaagi ni ini. So, hinumdum ba mo tong sa bunawan man to? Electrician siya sa Aselco. Nya karon kay di ba kuan lagi na siya kabalo lagi na sila no nga unsa kakusog ang mga kuryente nga na unsa dili na pwede matandog. Pero kato sadto say gyud siya. Nya bata pa gid siya. So nagroto siya nahikapan natamakan bato niya kay sa kami siya posting nga grabe mga kuryente. Nya nabay may nga mga live nabay na mga live wiring ana. So muto namatay siya kay nakuryentihan siya. Siguro na touch ba to niya o natamakan unsa ba diya o napilit ba siyang lawas. Kalit siya kirig. Patay siya. Munang di gid basta-basta magpa atik-atik aning mga kuryente no kay delikado gid kay siya. Para sa tuwa. Kay beta kabaluan na. Sila gay nga kabalo makuryentihan pa manggani. No, kani siya mo ni siya ang gamit ani purpose. So dili na pod ang resistant measurement gi ko na pod niya no. Gi test na pod niya so dili nituyok na pod siya nibalhin na pod. Nibalan so na screen dili makita kung unsa ka kusugon kay person ng 240.1 ingana mo na yung kakusugon na kanbali nakita na siyang screen sa multimeter. So diri na pod ang current measurement. So diri gitry niya sa battery, gi-connect niya sa battery. Kaning battery is ga-provide siya og energy. So gahatag gyapon siya og kanang energy ngana. So diri gitest niya. So mo ni no. Kita na to nga nituyok siya so diri ni butang gyapon siya sa asa ni dapit di makay maklaro ngana. O nakita gyapon to siya nga nakuha gyapon usa ka kusog unsay kayan niya. So iyang range is EC320. Ako so di gyapon kay battery no. Pwede kay siya. Di na pod sa dude test. O gitry na pod niya. O nituyok ra gihapon siya. So the electrical circuit. So ang kaning electrical circuit can be compared to a simple hydraulic circuit. So diri example kay sa battery. Diri nagikan sa battery ang energy niya. Kaya mo naghatag og ga-provide og energy. Then paingon siya sa ammeter. Pantod sa motor. Kaning motor man ang voltage drop. So, ang kaning next is kaning pump. Paingon na po siya sa flow meter. Hantod ba kapag sa pump pressure drop. So, kaning battery o pump, source of pressure ni sila. Then, flow rate paingon na yun sa resistance to flow. Nga na. O kaning digital meter bitaw. Walang i-addition no nga. Kanang pinagi nini kay mahimong gamiton sa pagkasukod sa lain-laing mga katangian sa kuryente. Kay naglakip nga kanang mapadali sa mga electrician nga ma-detect nila unsay mga problema ingana asa dapit ang dili mosiga ani asa ang unsa ka kusgon ang kuryente niini ingana siya. No, madali ra siya pag gamit dili na ka maglisod isip usa ka electrician. So next data sa types of loads. So naay resistor, inductor and capacitor. So resistive load. In DC circuit, the voltage and current waveform are straight lines because voltage is constant. In AC circuit, with pure resistance, voltage and current are always in phase. Power consumed in DC circuit is constant as voltage and current are constant. An AC that has only resistance produce a positive power curve. So ang kaning resistive load, ang kuan niya is kanang a circuit element that resists the flow of current, converting electrical energy into heat. Example ani is ang light bulb. Mo ni siya ang gitawag nga a resistor. So next is the inductive load. An inductor is a coil of wire. A common inductive load is a electric motor. Current lag behind voltage by 90 degree since voltage is max at 90 degree while current is zero. Produce both positive and negative power. These power are equal in amplitude, so their sum will equal to zero. The inductor does not use real power. Still generator supply it with voltage and current. So efficiency is lowered. So ang kaning inductive load pod siya is kanang a circuit nga element that store energy in a magnetic field. So example ani is ang electric motor, a coil of wire. Mo siya gitawag pod nga inductor or inductive. Tawag siya inductor kana itong mga electric motor, na siya. So the last is the capacitive load. A capacitor opposes change in voltage. Current lead voltage by 90 degree since voltage across it is zero and the current is maximum. Produce both positive and negative power. These power are equal in amplitude so their sum will equal to zero. The capacitor does not use real power. Still generator supply it with voltage and current. So efficiency is lowered ang sa capacitive load. So, capacitive load is a circuit element that store energy in an electric field, unlike a resistive load which dissipates energy as heat. A capacitor store energy and releases it later. So, that's the end of our discussion.